hi every student. Today I will continue our lesson. There's a lesson 8, element and also substances. Okay, let's see the 8.1. 8.1 we start with the metal. Okay, from this one metal we can divide by 3 types. We got atom, molecule and ions. Okay, molecule is a basic of the unit for every element. There's a one of the smallest of the particle. Okay, molecule. Molecule is a combine with the atom, 2 or more. They combine together by using the chemical. Okay, after that, after combine, they can using the same atom. They also can using the different atom. Okay, when they just combine, we call it as a molecule. Okay, ions. Let's see what means of the ions. Ion is a one of the charged particle. We can say ion as a positive. We can say ion also is a negative. Okay, it forms when the atom they lost energy or they gain the electron. Okay, now we need to go is one by one. Let's see the first one, atomic substances. Okay, atomic substances is made up with the atoms only, just atom. Okay, atom example here we can say there's a metals. We also can say there's a gases. So example here, see the diagram, we got balloon. Inside the balloon we got helium gas. So that means inside the balloon they just got one type of the atom, there's a helium. Okay, another example here, there's a gold metal. Gold metal is a solid state. Okay, inside the gold metal, they just got molecule, they just got the atom of the gold only. Okay, so from here, how about the arrangement? For the solid, sure the arrangement particle for the atom must be closer. Okay, how about the helium gas? For the gaseous, the molecule, the particle of the atom must be far away to each other because that one is a gas. So for example, what is the example for atomic substance? We got gold, iron, and also copper. Okay, second one is the molecule substances. Okay, before that, we're talking about molecule is a 2 or more atom they combine together. So most of the molecule, there's a non-metal substances. Okay, so example here we got inside the oxygen tank, we got oxygen molecule. Okay, oxygen is a molecule because they combine with the 2 atom oxygen. So when they combine become 2 oxygen, we call it as a molecule. So another one example, there's a water molecule. Water molecule is a combination of the 2 different atoms. We got hydrogen, we also got oxygen. So that's why we call the water as a H2O because we got 2 hydrogen, 1 oxygen. So after combine, this one is a molecule substances. Okay, molecule also can be created by reaction between the non-metallic element from a compound. Okay, for third one is ionic substances. Okay, can you see the diagram? This one is an example for the sodium chloride. This one is a common salt. Okay, inside the common salt, there all is ion substances because sodium ions and also the chloride ions. Okay, this one they form by reaction between the metal element and also non-metal element. Okay, after that is substances, positive ion and also the negative ions. So this one is how we go to differentiate atom, molecule, and also ionic. Okay, now we need to go the detail for the properties for 3 of the element here. Okay, first one is the atom. Can you see the arrangement for particle? There's a closer. Okay, second one is the molecule. The third one is the ions. So condition of the room temperature for the atom, there's a solid. Normally it's a solid. Just except the mercury. Mercury is a liquid. For the molecule, they got 3 states, either solid, liquid, and also the gas. For the ion, they're also in solid state when there's a room temperature. Okay, arrangement for the particle. Arrangement for particle, solid sure is a closer. Then how about another solid for the ions? They're also very closer. Okay, for the molecule, we need to separate by 3 types. Is solid, they're sure close, very close. Liquid just close, then the gas is far apart. Okay, third one, we're going to see the properties for forces attraction between the particle. Okay, forces attraction for the solid, sure is very strong. Okay, so for the atom and also ions, the forces attraction for the particle must be very strong. For the molecule, there's a weak. Okay, after that we go number 4 properties, melting point and boiling point. For the atom, they got high melting point and high boiling point. Iron also same, but the molecule is a low. Okay, the last one, electrical conductivity. For the atom, they can conduct electricity either in solid, either in molten state. Molten state means a liquid state. For the ions, they can conduct electricity just only in molten state. That means in solid, they cannot conduct electricity. Okay, how about the last one? There's a molecule. Molecule does not conduct electricity. Okay, let's see some example here. For the atom, example here we got all metal. Example, iron, copper, and also the gold. For the molecule, there's all non-metal. So from here, they got example, there's oxygen, ammonium, water, and carbon dioxide. Okay, last one is iron. Normally, the iron, the name, they got double. Because they got positive and negative ion, is it? So the name, they combine together. So they got double name. That means 2 words. So the first one, the example here is a sodium chloride. There's a normal salt. Okay, number 2, there's a lead 2 bromide. Okay, number 3 is a copper sulfide. So you can see the word, they got double. Okay, copper sulfide, sodium chloride. So this one is a ions element. Okay, for this one, they ask you one of the question. Can the same element that exist in the different form? Okay, actually the answer should be can. Okay, although you are same element, but when you happen some of the reaction, then they will change about the form. So from here, they depend the condition of the element, which produce the atom, ions, and also the molecule. For example, here we got ions. There's a head of the hammer. When starting the ions, here is there's an atom. Okay, all the iron is an atom. Okay, after you use for longer time, maybe they rust already. When they become the rust, now the iron that exists in the form of the ions in rust. So you can find it the molecule, the atom, they will changes become of the positive and negative charge. So this one already become ionic substances, although they are the same element, iron. Okay, another example is a hydrogen. Okay, let's see the hydrogen. Hydrogen exists in the form of the ions, lime juice. Okay, before that, hydrogen exists in the form for molecule, there's a water. Okay, remember, the water, there's a molecule, is it? When starting, there's a water. Okay, after that, they join. Hydrogen exists in the lime juice already, they will become the ions. So can you see the positive and negative ionic substances? So this one means a 2 example, although it's the same element, from the different condition, they will changes the form. Okay, we're going to see the next one. This one is a periodic tables of the elements. Okay, we need to know about this table, how to form, how to arrange. Okay, let's see the first part. We go by vertical. Vertical is from the bottom go up. This one called vertical. So vertical, we call it as a period. Okay, that means we got how many period here? We got 18 periods. Okay, we got 18 periods. 1, 2, 3, 4. Then we need to count lah. Okay, go to horizontal. Horizontal, we call it as a group. Okay, as a group. Okay, so from here we need to see. The group got 18. Because group we count at the top. Can you see 1, 2, 3, 4, 5 until 12, 13 until 18. Okay, period we count by vertical, is it? So vertical means you count 1, 2, 3, 4, 5, 6, 7. Okay, we count by vertical. Then just now the group is a horizontal. So from here we go to explain. Vertical column, there's a group. They've got 18 groups here. Okay, 18 groups. Horizontal, they count by row. Okay, count by row. We got 7 row here. So we can call it there's a 7 periods. Okay, after that at the bottom we got 2 special one. There's a series element. They start with the proton number 57 to 71. And the last row is from the 89 to 103. Okay, so this one is a structure for the periodic tables. Okay, first one, the series one we call lanthanide. Another one, the series, second series, we call it actinides. Okay, now we're going to see this one periodic table. Every box they got element. Okay, let's see the first one, H hydrogen. Okay, they show the proton number. Okay, after that they show the relative atomic mass. What's the mass of this one, hydrogen? Okay, let's see the arrangement. Can you see the green color? All the green color is a metal. Okay, the blue color start with the 13 group. You find that this one is a semi-metal. That means half of the metal. For the yellow part, this one yellow part, we start with the 14. This one is a non-metal. Okay, so that means the arrangement for the periodic table, they from the metal to semi-metal to non-metal. So from here, there's a moving from the left to the right. They change by the chemical properties. Okay, from the chemical properties and physical properties. Okay, chemical properties means they from the metal become non-metal. Okay, physical properties means the number. Can you see the proton number? The proton number keep increasing. 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10. So from here, metallic properties to non-metallic properties. Okay, number 2, from the basic to the acidic. Okay, C is decreases in the electrical element. So if you go to the left, to the right, you find it the electrical element that will decreases. Okay, the elements are arranged in order, increasing proton number. How we go to arrange? Which one want to put the first one? So this one arranged by based on the number of the proton. So from the left should be the smallest. Go to the right, the number proton will be increasing. Okay, let's see the example here. Electron arrangement for element. So this one is one of the atom. Okay, neutral atom. Okay, inside we got nucleus. Inside the nucleus we got proton. We also got neutron. Okay, for the neutral atom, proton number and also the neutron number, proton number and also the electron number should be the same. So example, if I say proton number here, you got 6. So your electron number also must be equal to the 6. So this one we call neutral atom. Okay, now we're going to see the orbits. Okay, orbits, the first orbits, we call it first shell. They can put how many electrons? They can put 2 electrons only. First shell, 2 electrons. Second shell, the maximum you can put is 8 electrons. Okay, and the third shells, maximum you can put 18 of the electrons. So the electrons are arranged in the shell around the nucleus. Inside the nucleus, we got what? We got proton and also the neutron. Okay, let's see the example for electron here. Okay, this one is a sulfur atom. Okay, sulfur atom using how many shells? They got 3. Okay, we go to separate one by one. Proton number, they got 16. Okay, 16 of the proton number. Okay, then the electron also 16. So this one we can call it as a normal neutral atom. Okay, electron, they arrange the first 2 one must be arranged by the first shell. Okay, so after that, 16 you minus 2, after that you still got 14, is it? So 8 that you put in the second shell. Okay, after put the 8, now you got 10 already. So what you left? You left 6 more. The remaining 6 that we put inside the third shell. So how you write the sulfur atom? There is a 2, 8, 6. First shell, 2 electron. Second shell, 8 electron. And the remaining we put at the third shell. Now we're going to see the formation of the positive and negative ions. How to form these ions. Okay, neutral atom for the ion, there's a donating the electron and also accepting. So you want to create, you either donate or either accept. So this is to achieve the stable duplet and also the octet electron arrangement. Then we need to see what means of duplet, what means of octet of the electrons. Okay, now we're going to see the 2 types of the arrangement. The first one we call duplet electron arrangement. Second one is the octet electron arrangement. Okay, let's see what's the difference. Okay, duplet electron arrangement means the first cell, they must full with the electron. There's just only 2, is it? So this one we call stable electron arrangement with the 2 electron in the first shell. So we call duplate. Okay, otate means the electron at the second shell. The second shell, we make it become stable. Arrangement must be 8 electron in the outermost shell. So this one we call otate electron arrangement. Okay, then we go to the positive and negative ions. When an atom they donate or accept any electron, the atom charged particle, we call it ions. So we don't care they donate or they want to accept. So when they just do this one process, we call it as ions. So example here, positive ions, they form when the metal electron, when the metal element, they donate electron. When they just donate, so we call it as a positive ions. Okay, how to produce a negative ions? When the atom, there's a non-metallic element that accept the electron. When the electron, they just accept, we call it as a negative ions. Okay, let's see example how to form the positive and negative ions. So first one we show there's a positive ion, aluminium 3+. Okay, that means they got 3 electrons. Okay, let's see the first part, aluminium atom, we got 2, 8, 3. So what you extra? At the third shell, you extra 3, is it? So from here, they want to create the stable atom, so they need to donate. They donate of the 3 electron. Okay, when they just donate become to the 3 electron, so you find it, the second shell full already, they don't have any third shell. The third shell already convert become the positive ions. We say positive charge, there's a positive ions. So from here we conclude the first part, aluminium, the proton number is 13. So the number electron also 13. The first part, no charge. That's a neutral. That's still atom. Okay, after that, when they just do the process of donation of the electron, okay, now you see the number become 2, 8. Number of protons still the same, 13. But now the electron become 10. Okay, 3 more will convert become the charge. So we say there's a positive 3. So this one situation, we no more become atom. There's a aluminium ions, positive ions. Okay, then we're going to see how to form negative ion for the chlorine. Okay, chlorine, when starting, they got 17 proton number. Okay, 17 proton number. The electron also got 17, charge 0. So this one we call there's an atom of the chlorine. So we write it 287. Okay, that means the third shell, they got 7 electron. Okay, now number of the protons still the same, 17. Okay, but now number of the electrons, they become 18. The extra 1 of the electron. So now we become charge -1. So the extra 1 of electron, why? Because they accept 1 of the electron. So the outer space, the third shell, now they got 8 electrons. So then you put here negative. Okay, remember, accept the electron means you take 1 more electron to come in. So after that, you got negative charge. Just now is you donate the electron. You donate the electron means now you got extra of the charge. Then you put positive. How many? Okay, now this one is an example formation for the lithium. There's a negative, there's a positive ions. Okay, let's see example lithium. Lithium, they got 3 proton. Okay, 3 proton, how we draw the orbit. First orbit, they got 2 electron. Second orbit, we just got 1 electron. So this one electron later, we need to donate. Okay, I donate, I become the doublet. Okay, so when I just donate, okay, they got 1 of the positive charge here already. So from here, we can say electron arrangement to 1. After donate, become 2. Okay, so from here, we can say, now the charge of the proton, 3. Proton is a 3. We never change anything. Okay, charge of the electron become 2 negative. Okay, become 2 negative. Okay, why become 2 negative? Because you got 1 more. 1 more already take out. So this one total charge actually is a 3. Because you 1 donate. So from here we can say what should be excess. Excess one of the positive charge causes become positive ions. Because you extra one of the positive charge, so this one become ions. Okay, so from here the lithium atom, they donate one electron to form the lithium ion. So the lithium ion that achieve the stable doublet, electron arrange 2. Now we're going to see the formation for the oxide ion. There's a negative. Okay, there's the formation oxide O2 actually is oxygen. So from here they want to form become negative. If form become negative, that means you need to receive. Okay, let's see the explanation. Electron arrangement 2, 6. Okay, now you want to make the second shell become full, must be 8 electron, is it? So you need to accept 2 of the electron to come in. So from here they will make it become 2, 8. Okay, now we go to analyzing the charge. Proton we got 8 positive. Okay, the electron we got 10 negative because you want to make it become round number. So 8 plus 2 become 10. So now how many charge is the extra? There's a 2 negative. Okay, positive got 8, then the negative you got 10. So your total charge extra is a 2 negative. Okay, so from here, the excess of the 2 negative charge that causes this whole thing become negative ions. So from here, we can say the oxygen atom, they receive 2 of the electron to form the oxide ion. So the oxide ion achieve the stable octet electron arrangement in 2, 8. Just now is a doublet. Now this one is an octet. Okay, let's see the 8.3. 8.3 is an isotope. So from here, we need to understand what means an isotope first. Okay, refer the diagram here. We got 3 of the diagram. That's a hydrogen diagram. Okay, let's see the first one. Hydrogen, they just got 1 of the proton number. Second one, we didn't call hydrogen. This one we call deuterium. Deuterium also 1 proton number, but they got extra 1 of the neutron. Okay, the third one we call tritium. Tritium is a 1 type of the hydrogen. So this one got 2 electron. So these 3 combined together, we call it as an isotope. So from here, we can find it. Isotope, proton number should be the same, but the neutron should be the different. So from here, some of the atom with the same number of the proton, but different number of the neutrons. So this one we call isotope. So now we're going to see
these two atoms are isotopes of chlorine. They have different masses because their nuclei contain different numbers of neutrons. One contains 18 and the other 20. It was found that out of every 4 chlorine atoms found in nature, 3 have atomic mass equal to 35, and only 1 atom is characterized by atomic mass of 37. Based on these data, it was calculated that the average atomic mass of chlorine is 35.5.
Okay, this one is one of the video they want to show about the isotope. Okay, example for the isotope. This one is an example. You can see some example. The name should be the same, just the proton number also same, electron number also same, just the number of the neutron changes. So this one is got 3 types: hydrogen, carbon, and oxygen. Okay, now we're going to see the symbol of the calcium. Okay, this one is a Ca, is an element for calcium. Okay, let's say at the top 40, down is a 20. Okay, 40 actually what's the name? 40 is a nucleon number. What means a nucleon number? Nucleon number is a total number of proton and also the neutron. That means proton, you plus neutron, we can call the name nucleon. Okay, 20 is the proton number. That means this one number they show they got how many proton inside the nucleus. Okay, now we're going to see the uses of the isotope in the various fields. Okay, radioisotope is an unstable isotope. They emit the radiation. Okay, let's see the radiation isotope they produce. They use where we use it. So we can use it in the medical field. We also can use it for agriculture, industry, power generation, and also some research. Although I know that one is harmful, but they still got uses. Let's see an example for the medic. Okay, medic we're using the gamma. Okay, remember the gamma ray using for the cancer treatment. So gamma radiation from the cobalt-16. Okay, what you need to remember is cobalt-16. Then you need to remember also is a function. So cobalt-16 they used to kill the cancer cell. So this one is normally using for cancer treatment. Okay, for the food technology. So food technology, they also got gamma radiation. They formed by cobalt-60 also. This one they use to destroy the microorganism on the veggie. So that means now you buy the vegetable, there's a fully beautiful, don't have any hole because they already put the gamma radiation. Okay, now we go to third one, agriculture. Agriculture, they put phosphorus 32. It's injected into the roots of the plant to study the fertilizer of the plant. So that means they want to make sure the plant is more healthy. So that means they put the phosphorus. They insert injection the liquid inside the roots. After that, you can find the plant can grow well. Some of the example here, you can see the industry. They want to detect the thickness of the paper. They're using the strontium-90. Strontium-90 is one of the isotope. Okay, after that we got uranium. Okay, created by the nuclear reactor, nuclear power station. They're using the uranium. Okay, after that we got carbon-14. Carbon-14 is used to study the age of the ancient. That means the object, the human already died how many years, they can detect by using the carbon-14. Okay, the next one also carbon-14. They use for determine the age of the rocks. Rocks also can be using this one carbon-14 to trace. Okay, cobalt-60 again, there's a gamma ray used to kill the cancer cell in the body. Okay, after that we got medic some more. There's iodine 131, also gamma radiation. They used to detect the malfunction of the thyroid gland. Okay, then we cobalt-60 again. They got sterilizer the food and prevent the potatoes, onions, and the ginger from the sprouting. So that means the food can keep for longer. Okay, after that phosphorus 32, they're for the agriculture. This one want to determine the rate of the absorption of the phosphate fertilizer in the plant. Okay, last one, again, the 14, carbon-14. They used to study the path of the carbon in the photosynthesis of the green plant. So this all is an example for the isotope. Okay, what we use it. Although there's a harmful, but they got uses for the human being. So now this one is a whole chapter 8. So what I want you to do is, let's see your textbook, page 174. This one is activity 8.2, formative practice. So you need to copy the question and answer it. So the answer I will give you for the next lesson. Okay, beside this one, also need to do 8.3. Also same, copy the question and answer it. Okay, just a simple things only. So hopefully you all can answer all the questions, including the module you take from the school. Is it the module? You help me to do the chapter 8 module. Okay, every student, hopefully you understand what I'm talking about. So our lesson just until here. Thank you for your watching.